Hello and welcome to today's video where we're going to talk about angle bisectors. So first let's get into the formal definition of an angle bisector, and that is a ray that from the vertex of an angle into the interior of the angle forming two congruent angles. And that kind of is a little confusing, but basically an angle bisector is a ray that cuts an angle into two congruent parts. So it's going to cut it down the middle, and the two sides that it's left with are going to be congruent. So look at this example here. Let's label this just so it's a little easier to see. So we have triangle ABC, and then we have segment BD is an angle bisector. And what angle did it bisect? Is an angle bisector of angle ABC, right? Because it cut angle ABC into two congruent parts. I see that because segment BD goes right down the middle, and then on the left hand side I'm left with 35 degrees, and on the right hand side I'm left with 35 degrees. So it's an angle bisector because it cut the angle into two congruent parts. That's what angle bisectors do every time. And so the good thing is, a lot of the times in geometry, what they're going to tell us is they're going to give us a triangle, maybe like this or something, and let's label this one ABC as well. Then they'll tell you like let's say CB, so they'll say CB is an angle bisector. And then you have to be able to figure out, well, what do I do here? So CB is an angle bisector. Well, you need to, well, not CB, CD. We're going to have to add a side in here. So CD is an angle bisector. Then you need to be able to draw this, draw the angle bisector, and then say that's D. And then say, okay, well, I know that this now is congruent to this. And this is something that you might have to use in proofs. It's something you might have to use in kind of like algebra problems, but you really just need to know the definition of it. So that's what we're focusing on here. Just know what an angle bisector does. It breaks a larger angle into two congruent smaller angles. So now let's look at a problem that you might see on some homework or something like that. So assume segment BD bisects angle ABC. Okay, and then now you need to find the measure of angle ACB. So I'm going to write in what angle I need to find. So ACB, which one is that? That's this one right here. So I'm going to label this one X because that's what I'm looking for. And then now let's try to use what we were told to help us find this problem out. Assume segment BD bisects angle ABC. So angle ABC is this whole angle here, but I know that BD bisects it, so that means it's going to break it into two congruent parts. Oops, let me get that gone. Yeah, there we go. Okay, so now we know that segment BD broke ABC into two congruent parts, and we know that one part equals 40, so that means this part has to also equal 40, because that's the definition of an angle bisector. It's going to break the angle into two congruent angles. So that helps, but I'm looking for X. How do I solve for this? How does that help me solve for this, basically? So this is actually a couple step problem. It's not as easy as we would like, because I know that X, if I do 180, I'm kind of given two triangles, right? I'm given triangle BDC. I see that one here on the right hand side, triangle BDC. I know that I can do the 180 minus 40, and that should help me get X, but I also have this angle that I don't know. So I can't just do, well, all the angles have to add up to 180 and kind of back out that angle from there. So I had to think of something else. But if I know this angle here, that can help me solve for angle BDC. So if I can figure this one out, that'll help me a lot. And what I can solve for that one because I have two of the angle measurements for that triangle. So I can do 100. So this is for triangle ABD. To solve for this side, I'm going to label that Y. To solve for Y, I can get angle BDC, this one right here. That can help me solve that. So to solve for Y, I'm going to solve for the triangle and just find that missing side. And what you do for that is you do 180 equals, well, it's got to equal 40 plus 65 plus Y. And then that's going to be 105, so 180 equals 105 plus Y. Subtract 105 from both sides. And I'm going to be left with Y equals 75. Yeah, 75 equals Y. So I know that this angle is now 75. And now I want you to think, how does this help you solve for this last angle here? Let's label this one Z. How does it help me solve for Z? If I know that that's 75, Well, this AC, the line here, is a straight line, so I know that that has to equal 180. So Z must be 180 minus 75 degrees. So 180 minus 75 equals Z, and that's because it's a straight line on the bottom. So 180 minus 75 is 105 equals Z. So I'm going to be left with Z equals 105 degrees. And now I finally have enough information to solve for X, which I wanted to solve in the first place. I can do 180 equals 105 plus 40 plus X. So 105 plus 40 equals 145 plus X. Subtract 145 from both sides. I get X equals 35 degrees. And that's the answer to our actual problem. So I'm going to write it as measure of angle ACB, because that's what they wanted me to find, equals 35 degrees.